All right, let's talk about data lakes. We all know they can be incredibly powerful or, a complete and utter mess. Today, we are diving deep into a technology that is seriously changing the game, Apache Iceberg. We're going to see exactly how it brings some much-needed order to the chaos of the modern data lake.
So let's just be real for a minute. That data lake you have, is it the flexible, super scalable asset you were promised? Or does it feel a little more like a chaotic swamp? You know the kind, where data just seems to disappear, trying to update anything is a total nightmare, and none of your tools can seem to get along. If that sounds even a little bit familiar, hey, you are definitely not alone. It's a huge headache for data teams everywhere.
And this slide, well, it lays out that gap perfectly. The promise was this amazing, flexible world where we could store anything cheaply. But the reality, especially with older table formats like Hive, is just messy. We're talking unreliable data, schema changes that feel like they could break the entire system, and zero coordination between your tools. It's a classic case of a fantastic idea that's just been really, really hard to execute.
And this all leads us to what we can call the data lake dilemma. It's that massive gap between what we were promised and what we actually have. It's the core problem we absolutely have to solve to make these giant data repositories actually reliable for analytics.
So the big question is, how do we fix it? Well, this is where Apache Iceberg comes into the picture. It's the modern solution that was literally designed from the ground up to fix these fundamental problems. But what is it really?
Okay, so at its heart, Iceberg is not a new database. It's not a new file type, and it's not a query engine like Spark or Trino. It's something way more fundamental. It's a table format. The best way to think of it is like an open rulebook. It's a spec that lays out exactly how a bunch of data files sitting in your lake should be seen and treated as one single organized table. The shared rulebook is the key that lets all those different engines work together safely.
And if we drill down a little, we see it's built for enormous scale. It basically brings the reliability we've always expected from traditional SQL tables, things like safe updates and consistent reads, right into the messy world of the data lake. And one of its core principles is being agnostic. It doesn't care if your data is on Amazon S3 or some old HDFS cluster, and it doesn't lock you into one query engine. That openness, that's a really big deal.
All right, now for the really cool part. Let's talk about Iceberg's key superpowers. These are the features that directly attack the problems we were just talking about.
First up, ACID transactions. Now this is a concept straight out of the database world. It guarantees that your operations are atomic, consistent, isolated, and durable. What does that mean in plain English? It means you can have lots of different users or jobs writing to the same table at the same time without completely corrupting your data. Every single change either finishes successfully or it doesn't happen at all. No more broken, half-finished updates.
Superpower number 2 is an absolute lifesaver for anyone who's ever had to deal with a data model that, changes. It's called schema evolution. This is the magic ability to change your table's structure, maybe add a column, rename one, change a data type, without having to rewrite terabytes of old data or breaking every query that depends on it.
For example, let's say we realize we need to add a category column to our sales data. In the old days, with old formats, this would be a massive, risky, all-hands-on-deck operation. With Iceberg, you just declare the change. That's it. Iceberg's metadata takes care of the rest, making sure that both old and new data can be queried together perfectly. It's amazing. No chaos, no downtime.
And finally, we get to one of my favorite features, time travel. This gives you the incredible power to query a table exactly as it looked at any point in the past. Need to reproduce that report from last Tuesday? Or maybe you need to roll back a really bad data load that just happened? Time travel makes this stuff not just possible, but actually pretty simple.
And this isn't just some vague idea, it's built right into the SQL. You can see right here, you can query a specific snapshot of your data just by using its ID or even a timestamp. This is so powerful for auditing, for debugging, and maybe most importantly for making sure your machine learning models are trained on a perfectly consistent snapshot of the data.
So, those are the superpowers. Pretty amazing, right? But how does Iceberg actually do it? How does it pull all this off? Let's take a quick peek under the hood at the architecture.
The real magic is in the write process. So when a change happens, Iceberg never modifies the existing data files, and that is the key. Instead, it writes brand new data files and then creates a new snapshot that represents the table's new state. And then comes the final, most important step.
It does an atomic swap of a single pointer in the metadata to point to this new snapshot. That one tiny, instantaneous change is what makes everything so safe and fast for everyone reading the table. This whole thing works because of a really clever, layered metadata structure. It all starts with a catalog, which is kind of like an address book that just points you to the current metadata file for your table. That metadata file is the absolute source of truth. It holds the schema, the partitioning rules, and the complete history of all the snapshots. Each snapshot then points to a set of manifest files, and you can think of these like detailed indexes that list out the actual data files and, this is the really cool part, they contain stats about the data inside. That's what makes queries so much faster, because the engine can just skip reading files it knows it doesn't need.
Okay, that's enough of the technical deep dive. Let's see how this all translates to the real world. Where are people actually using Iceberg to get work done today? So the number one use case by far is building a lakehouse. Trying to get the best of both data warehouses and data lakes. But it's also a huge deal for things like data auditing and compliance, which makes total sense thanks to time travel. And it's also being used to unify streaming and batch data into a single table. That multi-engine piece is also critical because it lets teams use the best tool for the job, like maybe Spark for big ETL jobs and Trino for quick BI queries, all on the exact same consistent data.
Now, to be fair, Iceberg isn't the only game in town. You've got competitors like Delta Lake, which has super deep integration but is often pretty tied to the Spark and Databricks ecosystem. And then there's Apache Hudi, which really shines at specialized things like incremental data ingestion. Iceberg's whole philosophy, though, is to be a truly open, vendor-agnostic standard. Its main strength is making sure that lots of different engines can all play nicely in the same sandbox without messing things up.
And that intense focus on openness really brings us to the main point. What does the future of our data architecture actually look like with technologies like Iceberg leading the way?
So if you remember one thing, it's this. Iceberg isn't just another tool you add to the pile. It's a foundational layer. It provides those reliable, open, and high-performance rules that finally let you turn that chaotic data swamp into a structured, trustworthy data lakehouse.
At the end of the day, when you're building at a massive scale, you have to have a solid foundation. And as this says right here, Iceberg provides exactly that. It's a foundational piece for managing tables in a way that is reliable, flexible, and fast.
And all of this leaves us with one final question to chew on. As our data platforms get more and more complex, with more tools and more users every day, is a real commitment to open standards like Apache Iceberg the only sustainable path forward? It's a big question, and it's one that data architects all over the world are thinking about right now. Thanks for tuning in.